Calculus, differentiation using log rules, and this includes the introduction to log rules. Very important to remember that a log is an exponent, so logs behave in the same way as exponents. Meaning that when numbers multiply, logs add. So log of a product is the same as sum of the logs. And for ln, the same thing. Ln of AB, ln A plus ln B, because quite simply ln of AB is ln of AB, log of AB to base E. So let's have a look from the previous video, which introduced logs. There we are. We differentiated that function. There, as a reminder, are the derivatives. Now we separated this. This is a product of three factors, so therefore ln plus ln plus ln. There it is there. Now to differentiate, that's a constant, so it becomes 0. Ln of e to the minus x, well, derivative of ln is 1 over, so it's 1 over e to the minus x, times derivative of the inside function, which is itself a composite function, so we end up with e to the minus x times minus 1. And ln of sine of x, well, 1 over sine of x times derivative of sine of x is cos x, and that simplifies there. Naught, negative 1 cos over sine, which is cot. Now there's the original working from the previous video, and you'll see already it is simplified quite a bit by being able to use the log rule. And when numbers divide, logs subtract, the same as exponents subtract when powers divide. So log of A over B, log A minus log B, all to base C, or ln A over B, ln A minus ln B. So let's have a look at the example 11, number 11 from the previous exercises. This was fairly complex to work out. Well, now we can separate it into a difference between two terms. Ln of the top minus ln of the bottom. There it is there. Now note that ln of a sum is not simplifiable. You can't say ln 1 plus ln e to the x. Please don't reverse this rule and say ln of 1 plus e to the x is ln of 1 times e to the x or something silly, or ln of 1 times ln of e to the x. This cannot be simplified. It's only if these were multiplying you'd be able to. So, using the rules, ln, derivative of ln is 1 over. So therefore, ln x, e to the x, 1 over e to the x times derivative of the inside, e to the x, minus 1 over that, times derivative of that for the composite function, chain rule, e to the x. Simplifying, that becomes 1, that becomes e to the x over 1 plus e to the x. Simplifying, common denominator, don't know why those two are written the other way around, but it's still correct. And becomes quite simply that. And it's a bit shorter, but certainly less complex than this one here, which had to use product rule, quotient rule. Raising a number to a power, and the same thing happens. Log of a to the n is n log a. Let's have a look at the reasoning behind this one. A to the n means a times a times a n factors, which means we're going to log a plus log a plus log a n terms, and if you add n of the same terms, it's the same as n of that term. There it is there. And of course, ln of a to the n becomes n ln a. Don't confuse this with multiplying down by the exponent with differentiation. This is very different, but with lins and logs, the exponent can come down to the front. Not if the whole of ln A was in brackets with an n there, but we'll see one later with that. There it is there. Ln of x all to the n is not equal to n ln x. It's only if it's ln of, and then it's x to the n. But this is the whole of ln of x to the n. Let's have a look at example 10 now. We're going back to example 10 and it becomes simpler still. Because now we're going to separate that into 3 terms. But now I've brought that negative x down to the front. Instead of plus ln e to negative x, I've said minus x ln e. Now of course ln e, that means ln of e to base e is 1. So x ln e becomes x. Now, when we differentiate, we get that. Which, look how much simpler than that one. Right, let's have a look at some examples. This would be pretty complex to do usually. We'd have to do it by a composite rule, which then goes further, where we'd have to say 1 over that times, and then derivative of that, which in brackets will be by product rule, where these are both composites as well. But now look what happens if we use the log rule. So first of all, ln of 2 factors multiplying is sum of the logs of the factors. Now we can bring the 3 and the 8 to the front. And look how simple that is, because when I differentiate that now, it just becomes 3 over x plus 5, because ln of x plus 5 differentiated becomes 1 over x plus 5. Notice that this is a composite function, but the derivative of x is 1, so we don't have to worry. This is 8 times 1 over 2x minus 1, but times 2 because derivative of the inside function, 2x minus 1. So we find a common denominator, and there is the result. Quite a bit simpler than doing it by other methods. Another case, looks quite complicated, but now we have ln of something to the half, which means I'll have ln of x minus 2 over x plus 9, and I brought the half to the front. And now I can separate this into a difference, so ln of x minus 2 minus ln of x plus 9, all multiplied by the half, that's why each has the half. And there is the derivative using that rule there. That 2 there is from the half. So ln of x minus 2 becomes 1 over x minus 2, and it's multiplied by half. Times 1 just to accentuate the fact that we're doing a composite rule, but the derivative of the inside is just 1. Same here. Common denominator, so we end up with 11 over the denominator. One involving exponential function e. Well, there we are. That divided by that, therefore it's ln that minus ln that. There we are. Now notice I cannot distribute the ln into that, so I have to differentiate as it is. Well, ln of that is 1 over e to the 3x minus 1. Ln of that is 1 over e to the 3x plus 1, but then I have to multiply by the derivative of the inside. So 1 over e to the 3x minus 1, derivative of the inside, e to the 3x again, but times 3, derivative of the inside. That goes, derivative of that is 0, same on this side. Common denominator, where I've taken out a common factor of 3e to the 3x there, and that simplifies 6e to the 3x over e to the 6x minus 1, or left like that. Some exercises to do. Try them yourself by pausing and doing them, and then look at the answers. So this is a product of 3 factors, so I separate it into 3 terms. That 1 minus x can come to the front. There we are, like that. Ln e is just 1. So therefore that goes, and I'll have 1 minus x. Ln 3, the derivative is 0. So all I'm going to be differentiating is ln x and 1 minus x. Ln x, 1 over x. Ln of 1 goes. Ln of 3 has gone. And minus x gives you the minus 1. And there I brought over a common denominator. In this case, we'd usually have to use a quotient rule, but I'm going to separate it into a difference between two terms. And that negative x can come to the front. And ln e is 1, so therefore it just becomes minus x minus ln x. Differentiating, derivative minus 1, derivative 1 over x, common denominator. Next one, we're going to have ln of the numerator minus ln of the denominator. We cannot find ln of each separately. That's set like that. So now I go into the derivative where I write 1 over that times derivative of that minus 1 over that times derivative of that. 1 over that, there it is there, times derivative of e to the 2x is e to the 2x again, times 2 being derivative of 2x. Same sort of thing there. Take it out a common factor of 2e to the 2x. This becomes a plus with a double negative. And there's simplest form. This could also be multiplied out, but I've left it like that now. This one here, well, let's put that to the half, because then the half can come to the front. We cannot write that as two terms, because it's not dividing or multiplying, these are subtracting. So the half is still there, 1 over that times derivative of the inside. Simplifies to that.